I'd like to introduce tonight's speaker, Mike Weber. Although Mike is a relatively recent volunteer at the museum, he has a long history and love of Cornwall. As a child, he collected rock and mineral specimens in and around the waste rock piles, and that led him to the study of geology. As a 1982 geoscience graduate from Penn State, Mike worked for 36 years as a geologist, health physicist, and manager for the U.S. Nuclear Regulatory Commission and the U.S. Geological Survey. After retiring from federal service, he returned to Cornwall Furnace, where he serves as a guide and researches the history of, the history of mining and the geology at Cornwall and similar deposits in Pennsylvania. One of Mike's ongoing projects is studying the monthly reports of the Cornwall division of Bethlehem Steel. This will allow us to have a better understanding of the operation, and we hope that this will lead to a publication in the future. So please welcome our speaker, Mike Weber.
Good evening, and thanks for joining us for this webinar on the mining of Cornwall. I appreciate your interest in the topic, and I also appreciate the support from the Cornwall Iron Furnace Associates for hosting this webinar. For more than 230 years, the mines at Cornwall played a significant role in the development and defense of the United States. Beginning in 1737, Cornwall produced iron that helped to colonize America, arm the colonials during the Revolutionary War, fuel the Industrial Revolution, build the skyscrapers of America's cities, and defend liberty and freedom during 2 world wars and the Korean conflict. Until the 1880s, Cornwall was the largest iron mine in the United States. And today, Cornwall remains one of the longest continuously operated mines in the Western Hemisphere, even though the mines closed nearly 50 years ago. By the conclusion of this webinar, I hope that you'll share some of my passion and interest in the mining of Cornwall. I plan to overview the mining, describe what the mines look like today, and thank the people who made this presentation possible. And I'll leave plenty of time at the end of the webinar for answering questions and listening to any comments you might share. My slides, you'll see, maximize the use of photos, diagrams, and maps, so you can get a better sense about what mining was like in Cornwall. This is my last word slide. So please join me now in the mining of Cornwall. Early visitors to the mines were astounded by the size and extent of the iron ore deposits at Cornwall. Aurelius described the deposits as rich and abundant when he visited the colonies from Sweden in 1759. Another Swedish visitor, Samuel Ermelin, described Cornwall as the richest iron ore fields in the United States in 1783. 100 years later, Dr. Eagle documented the history of Dauphin and Lebanon counties in Pennsylvania and described Cornwall as the most remarkable and valuable iron ore deposit in the world. And Pennsylvania state geologist Peter Leslie in 1892 observed that Cornwall showed no signs of exhaustion after nearly 150 years of mining. We will likely never know who actually discovered the iron ore at Cornwall. We do know, however, that Peter Grubb purchased the land in 1737 with the express purpose of mining the iron ore and producing iron in nearby Cornwall Furnace. The iron ore existed beneath 3 hills about 5 miles south of the city of Lebanon, Pennsylvania: Big Hill, Middle Hill, and Grassy Hill. Peter Grubb initially mined the ore in 1737 to demonstrate the suitability of it for producing quality pig iron in the furnace that he built from 1739 until 1742. And after the furnace began operating in 1742, mining occurred on a more continuous basis. During the first 50 years of mining, Cornwall supplied ore to 3 local furnaces: Cornwall Furnace, beginning in 1742, Elizabeth Furnace in 1750, and Mount Hope Furnace in 1785. When mining began, rich iron ore could be found on the surface of the ground, as seen in this current photo of the surface of Big Hill. The ore chunks, which you can see in this photograph as though dark brown chunks, are about 3 inches long and are highlighted at the tips of the 4 yellow arrows. Robert Coleman purchased the mines and the furnace from the descendants of Peter Grubb and took over the operations in the late 1700s. This early map of Robert Coleman's estate at Cornwall was drawn about 1800. The map was drawn in great detail and shows the Coleman mansion near the top of the drawing, and below that mansion is Cornwall Furnace. In the middle of the map, you'll see 3 brown areas which depict the mining pits on Big Hill, Middle Hill, and Grassy Hill. Mining began on Big Hill because it was the most prominent part of the iron ore deposit and most developed by 1800. In contrast, mining, as you can see on this map, was only beginning at this time on the deposits beneath Middle Hill and Grassy Hill. As we leave this slide, notice the dirt roads that emanate from the pits. These were used to haul the ore from the mine to the local furnaces. The shallow pits and trenches eventually grew into much larger open pit that's visible at Cornwall today. For the first 100 years of mining, 10 to 15 miners using hand tools, wheelbarrows, and mule-drawn carts produced enough ore to supply several furnaces. As mining operations expanded due to increased demand and improved transportation in the mid-1800s, greater cooperation and organization was required to operate the mine and increase ore production. The Cornwall Ore Bank Company was established in 1864 and organized the mining at Cornwall. And this map was prepared by the Ore Bank Company in 1873. By the time the map was prepared, mining was well established on all 3 hills. Miners gouged out the middle of Big Hill, removing most of the ore. The iron ore extended deeper beneath Middle Hill and Grassy Hill, so the map showed increased excavations in these areas, especially when compared to the previous map. These photos of mining on Big Hill were taken in the late 1800s. In the photo on the left, you can see miners using hand tools and mule-drawn ore dump carts around 1880. The dump carts transported the ore to local furnaces or transferred the ore onto rail cars. Rails are evident in the foreground of the photo on the right, which was taken around 1890. Rails were constructed as close as practical to the areas that were being mined to increase production and minimize the distance that the ore had to be carted before it was loaded onto the rail cars. These scenes were photographed around the turn of the 20th century, and both photos are located on Middle Hill with Big Hill seen in the background. In the photo on the left, look how close the railroad tracks came to the areas that were being mined, with the miners in this photo using hand tools to remove and break up the iron ore and wheelbarrows to cart the ore onto the rail cars. And in the picture on the right, you can see an early steam shovel that was used to expedite the digging of the ore from the pits beginning in the early 1900s. A miner standing in the foreground is holding a sledgehammer. He was likely what was called a pounder, one of the better paid positions among the miners. Pounders broke the ore up into small chunks that could be fed directly into the furnaces. Not too big, not too small, just right. As the miners excavated the ore, the pit grew deeper. And as the pit grew deeper, trains could no longer be used to remove the ore from within the pit. The photo on the left is from the 1940s, and it shows a shovel loading a 30-ton dump truck below Middle Hill. These trucks were custom made by the Mack Company for the mining operation at Cornwall. They carried ore from the shovels to a pit pocket at the crane, which can be seen in the background of the photo on the left side. At the pit pocket, miners dumped the ore into rail cars that were pulled up an incline. 3 inclines can be seen in the photo on the right. The first incline on the left of the photo is the main incline, or incline number 1, and it was built in the early 1900s by the Cornwall Ore Bank Company. The cars on the incline are called skips. The skips were hoisted up and down the incline using heavy cables from the hoist house on top of the hill. At the top of the incline, the skips dumped the ore where it was crushed and then loaded onto the rail cars. And this incline operated until surface mining was suspended in the open pit in 1953, after which the incline was dismantled. The incline in the middle of the photo was operated by the Robezonia Iron Company until the 1920s. The company purchased the right to mine and remove sufficient ore from Cornwall to supply one furnace. You can also see on the far right of the photo a third incline at the base of Big Hill. Shortly after the photo was taken, the ore was depleted at Big Hill and the incline was dismantled. As miners dug into the deposit at Cornwall, the concentration of iron gradually decreased in the ore. When mining began, the concentration of the ore was generally high, in the range of 60 to 65% iron. But by the 1880s, the concentration of iron decreased to the mid 40% range and was less attractive as feed for the furnaces. In 1904 to 1905, the Pennsylvania Steel Company constructed a plant on Lehman Street in Lebanon, Pennsylvania, to increase the concentration of iron in the ore. This so-called concentrator plant, or conci for short, ground the ore to finer sizes and used magnets to concentrate the iron in the ore. After the ore was crushed and the magnetic iron removed, the plant processed the ore further to recover additional metals, including copper, cobalt, silver, and gold. During a typical year of operation beginning in the late 1930s, Cornwall produced thousands of tons of copper, hundreds of tons of cobalt, and thousands of ounces of silver and gold. Cornwall developed the cobalt processing techniques in 1938, just in time to support the nation's defense during the Second World War. Cobalt was used in making steel alloys for armor plate. The concentrator plant in Lebanon operated until it was replaced by a similar plant at Cornwall in 1962. In 1916, Bethlehem Steel Corporation acquired a controlling interest in the mines at Cornwall, and shortly thereafter, in 1920, miners forecast that the pit would soon become too deep to mine before the ore ran out. So the company decided to construct an underground mine beneath the open pit to remove the remaining ore. The ore occurred in a large slab that was tilted at about a 30-degree angle toward the south. Look at the miners posed around the entrance to the shaft at the ground surface. Mining iron ore underground required skills that were different from those that were used in the open pit. So Bethlehem Steel hired miners with experience in underground coal mines in Pennsylvania and the Midwest, iron mines in the Great Lakes region, and hard rock mines in Mexico and Western and Eastern Europe. In the early days of underground mining in the 1920s and 30s at Cornwall, 16 different languages were spoken by the miners, in addition to dialects like Pennsylvania Dutch. Now, this map should help orient you to the locations of the mines that we'll be speaking about tonight at Cornwall. The top edge of the map is to the north. The Cornwall Furnace is located in about the center of the map. To the southeast of Cornwall Furnace is Miners Village. To the northeast, Anthracite and Rexmont. To the north, Cornwall Center. And to the west, Bird Coleman Village. You will note the large open pit west of Boyd Street, or the old Route 322. On the eastern end of the open pit is Big Hill. The number 3 mine surface plant is located in the red rectangle on the north side of the open pit, between Middle Hill and Grassy Hill. In 1921-1922, miners constructed an incline shaft about 1,600 feet long to a depth of 740 feet below the land surface, nearly 300 feet below the bottom of the pit. This shaft was named the No. 3 slope or shaft. The shaft was constructed on the north wall of the open pit. This photo, taken in 1953, shows the interior of the shaft before it was rebuilt, before resuming mining underground in the mine. A skip car used in the No. 4 shaft can be seen in the photo on the right. Skip cars were loaded with ore, waste rock, or miners and materials underground in the mine and were hauled up the shaft by the hoist at a speed of 500 feet per minute. As one skip ascended, another one descended on an adjacent set of rails, and each skip could carry up to 10 tons of ore, making 250 to 275 skip trips per day. In the photo on the left, you can see the rails on which the skip cars rolled on the left side of the shaft. When the photo was taken, the rails had not yet been placed on the right side, and in between the two skip compartments is what's called a manway, and that was used for the maintenance of the shaft or as an emergency exit for the miners. The No. 3 shaft accessed the No. 3 mine, which you can see in this map of the mine as though you were looking down on it from the mine from above. This map was prepared in 1954, about halfway through the life of the No. 3 mine. The dashed vertical lines that you can see here near the crease represents the location of that No. 3 shaft. On the left or west side of that line of the mine, you can see areas that were mined on the first, second, third, and fourth levels. The long tunnels or drifts that you see extending across the map, like this one, were constructed on the 6th level of the mine, and they connected to mining areas on the 6th and 7th levels in the east side of the mine. The No. 3 mine extended across 10 levels. No ore was mined below the 7th level. A large sump collected and pumped water out of the bottom of the mine on the 10th level. Groundwater flowed into the mine and frequently impeded production of iron ore throughout the life of the No. 3 mine. This picture of the No. 3 mine's surface plant was taken in 1951 and shows the No. 3 shaft. The skip cars ascended to the top of the tower or the head frame of the mine. And you can see that head frame right here. So there's the head frame and there's the shaft going down into the mine. Miners excavated the shaft and the tunnels or the drifts below the diabase because it was easier to maintain those tunnels. In the head frame, the iron ore was crushed and then cobbed to remove waste rock from the ore before it was transported using a long conveyor belt to the No. 4 mine at the No. 4 mine surface plant about a mile to the east. And I'll talk about the No. 4 mine soon. The waste rock was also transported from the head frame using a conveyor belt and then dumped back into the open pit in the western end of the open pit. Besides the No. 3 mine head frame, hoist house, crushers, and conveyors, the surface plant also included a dry house where miners changed their clothing before and after mining, a machine shop, material storage areas, and an office. Also note in this photo that the shaft for the No. 3 mine enters the ground well down on the side slope of the open pit and far below the lake level in the pit today. Now this vertical cross-section shows how miners extracted the ore in the underground mines at Cornwall. Although there were some differences throughout the lifetimes of the mines, the same mining approach was generally used in both of the underground mines. Miners excavated, as I mentioned before, below the ore into the trap rock or the diabase. The trap rock was generally stronger and required less maintenance to mine than the ore above. Once underground, the miners excavated horizontal tunnels. You can see one of those tunnels here called the haulage drift. And then there's more tunnels here called the slushing drift. And then they excavated upward through the diabase into the ore, where they set explosive charges and detonated the ore. That caused the ore to crush, and then it came back down through these finger raises. And when the ore entered the slushing drift, it would be pushed or pulled down to the haulage drift, where it would be loaded onto small rail cars. And those rail cars would take the waste rock or the ore to the loading slots that were located near the shaft of the mine. And that's where the ore was transferred into the skips. The skips hauled the ore or the waste rock out of the mine and up to the land surface. Well, now that you've seen the vertical cross section, now this map might make some better sense. The longer tunnels were the horizontal slushing drifts or the haulage drifts, and you can see them here. These are the slushing drifts, and then this line is a haulage drift because it would haul the ore once broken out of the body to the loading pockets where it'd be loaded onto the skips and then taken up the shaft. These circles represent cavities, or what were called bells by the miners, and that's where the miners drilled up into the ore body, detonated the explosives, crushed the ore, and then the ore came into the scraping drifts or the slushing drifts. The underground trains then moved the ore back to the dumping stations and then up the number 3 shaft. Between 100 and 150 miners typically worked in the number 3 mine. While some miners were removing the ore, other miners were busy preparing the mine to produce more ore by constructing new tunnels or drilling new ore chambers. From 1927 until 1941, miners produced most of the ore on the first and second levels of the mine, the first being the closest to the pit bottom. Mining in the number 3 mine was then suspended until most of the ore had been removed from the open pit above. Miners then resumed production from the number 3 mine beginning in 1953. And during the 50 years that the mine operated, it produced about 14 million tons of iron ore, an average between 10,000 and 50,000 tons of ore per month. Now, before we leave this slide, look at the uneven or squiggly areas around the perimeter of the mine. In these areas, the ore was not as thick and tapered out into the bedrock. And rather than using the cylindrical shaped cavities or bells, the miners excavated the ore in these areas called open stopes by just removing the ore and not the adjacent bedrock. We can see one of these open stopes in this photo, which was taken on the 6th level of the number 3 mine in 1957. That small figure that you see there in the distance is a miner with a light on his hat. So you can tell, based on the size of the miner, the approximate size of that open stope. Open stopes like this could only be constructed where the ore was thin enough and the adjacent rock was strong enough to support the weight of the rock overlying the mine. In time, of course, the rock above these mined out areas collapsed into the voids left behind. The collapse progressed all the way to the land surface, and this is the reason why mining in the number 3 mine was suspended until most of the ore had been removed from the open pit above. In the number 4 mine that we'll discuss next, the collapse of the overlying rock caused a large subsidence or collapse crater above the mine. And this large area today lies beneath the Iron Valley Golf Course and required the rerouting of US Route 322 in the mid-1960s. The number 4 mine surface plant is located in the red rectangle about a half-mile east of the open pit and the Cornwall Furnace. In 1908, a geologist from the U.S. Geological Survey forecast that additional iron would be located near Cornwall. In 1919, geologists found this additional iron ore extending from about 150 to 1,200 feet below the land surface. The ore had the shape of a large lima bean with a surface area of about 110 acres. In this vertical cross-section of the number 4 mine, you can see the number 4 and the number 5 shafts. There's the number 4 shaft. There's the number 5 shaft. You can see the collapse area on the land surface above the mine. You can see these horizontal tunnels, which are the haulage drifts. You can't really see the slushing drifts, but you can see the chambers going up into the ore where the ore was fragmented and then dropped down into the slushing drifts and the haulage drifts. The cavities in the number 4 mine were also grouped together into large areas called panels. So you can see here the first panel, the second panel, third panel, and so on. Beginning in 1924, miners excavated the number 4 and the number 5 shafts parallel to one another to access the ore in the number 4 mine. The shafts were about 2,400 feet long and extended to a depth of 1,250 feet below the land surface. At the surface, the angle of the shafts was 35 degrees below horizontal and gradually decreased with depth to 28 degrees. Like the number 3 mine, the shaft and tunnels were constructed in the trap rock about 100 feet below the ore. The miners traveled up and down in the number 5 shaft pictured on the right. Skips containing ore and waste rock were hauled up the number 4 shaft and dumped in the head frame pictured on the left. The ore skips were hauled at speeds up to 1,200 feet per minute to produce as much as 5,000 tons of ore per day, making 500 to 600 skip loads daily. In addition to the ore, the skips also hauled up to 1,000 tons of waste rock per day. Miners placed most of this waste rock in the core of Big Hill. Now here's a map of the number 4 mine as seen from above looking down on the mine, just like the map we previously saw for the number 3 mine. The number 4 and the number 5 shafts are these parallel lines that you can see on the left-hand side of the map. This is the number 4 shaft and this is the number 5 shaft. The area that you see in yellow is the portion of the ore that had been mined out between 1937 and 1952. In those years, a large amount of ore had been produced. And then during 1952, the year this map was made, the area shown in red was mined out of ore, and the area shown in green had been prepared for additional production the following year. The number 4 mine was both larger and deeper than the number 3 mine and employed up to 450 miners at any one time, although this number rose and fell depending on mining development and production activities at any given time. Once the ore was brought to the surface, it was crushed and cobbed similar to the process used at the number 3 mine. The number 4 mine produced about 1 million tons of ore a year during the 35 years that it operated from 1937 until 1972. Production of ore from the number 4 mine was hampered by large amounts of groundwater, just like the number 3 mine. And this groundwater flowed into the mine and had to be extracted by pumping. During some periods of mining, more than 2 million gallons of water a day were pumped out of the number 4 mine. The two diagrams shown in this slide depict how the composition of the iron ore changed throughout the ore body. The diagram on the left shows the concentration of copper, and the figure on the right shows the concentration of sulfur. These figures were prepared in 1965, and by that time the ore shaded gray had already been removed, and the portions of ore remaining were relatively low in copper and sulfur content. As I mentioned in describing the concentrator plant in Lebanon, Bethlehem Steel processed Cornwall ore to recover iron in addition to copper, gold, silver, and cobalt. As copper concentrations decreased, so too did the gold and silver. And similarly, as the sulfur concentrations decreased, so did the cobalt concentrations. Bethlehem Steel announced the construction of a new concentrator plant at Cornwall in 1960. And the new plant began operating by April 1962. The design of the new plant benefited from many years of experience that Bethlehem gained from operating the plant in Lebanon. These same designs were also used in developing the Grace Mine in nearby Morgantown, Pennsylvania, the Memora Mine in Ontario, Canada, and other mines located around the world. In this photo, you can see how the ore entered the building on the right, where the ore was crushed, magnetically separated, and then mixed with clay, moved over into this building where those clay pellets or balls were baked into the iron pellets that were then transported to the iron furnaces and then used. Meanwhile, back in the building on the right, other metal concentration processes were occurring. And you can see in the background of this photo the number 4 shaft head frame and the number 5 shaft head frame. And of course, both of those shafts serviced the number 4 mine. Production of the iron ore and the remaining ore reserves waned in the 1960s. And so Bethlehem Steel began to develop the East End ore body, so named because it was located in the eastern end of the open pit. Although the ore was relatively shallow and accessible through the open pit, it had to first be uncovered by removing about 4 million tons of rock and soil. And some of this rock and soil had been placed on top of the ore by miners who excavated the open pit during the 1800s and 1900s. The map on the left shows the rock in yellow that had to be removed before miners could begin removing the ore. To get the ore out of the pit, Bethlehem Steel decided to dump the ore directly into the number 3 mine from the floor of the pit, and then haul it out using the number 3 shaft. This approach took advantage of the equipment already installed and functioning in the number 3 mine. Although development began in 1964, the first ore was produced from the East End ore body in September 1970. And in that photo on the right, you can see the first dump of ore from the East End ore body into the number 3 mine. This ore arrived just in time as the amount of ore from the number 3 mine dropped to very low levels. All of the Cornwall mines can be seen in this photo taken in 1969. In the immediate foreground, you see the open pit and Big Hill. On the right side of the open pit is the East End ore body. And on the left and in the foreground is the number 3 mine. And in the distance, you can barely make out the images of the number 4 mine. Now, as early as the 1940s, Bethlehem Steel projected that the ore at Cornwall would be depleted in the 1970s. And by the 1950s and 60s, these reserve projections suggested that Cornwall would run out of ore by the early 1970s. In June 1972, Hurricane Agnes formed in the Gulf of Mexico and traveled up the east coast as a tropical storm before she joined forces with a low-pressure system over the eastern United States. As seen in this map showing cumulative precipitation amounts, the storm collectively dumped an average of 12 inches of rain during a several-day period over most of central Pennsylvania, and that included 19 inches over Schuylkill County, just north of Lebanon. The photo on the right shows flooding of the open pit from runoff and the failure of a 42-inch diameter pipe that diverted Furnace Creek around the open pit. But the real damage from the flooding occurred back in Lebanon, at the power plant that serviced the mines, when local flooding took out a frequency converter that caused the loss of power to the pumps in both number 3 and number 4 mines on June 22nd. By the time power was restored on June 24th, the lower levels of both mines were flooded. In July 1972, Bethlehem Steel decided to close the underground mines permanently. Given the small amounts of ore remaining in both mines, it would have been too costly to pump out the mines and rebuild the pumps and other equipment that would have been required to complete the mining. Instead, Bethlehem focused its attention on removing as much of the ore as the miners could extract from the East End ore body during the next year. From August 1972 until June 1973, the open pit served as the sole source of ore for the Cornwall mines. After nearly 235 years of continuous mining at Cornwall, the first mine developed at Cornwall served as its last source of ore. The photo on the right shows the last truck of ore leaving the open pit on June 30, 1973. After mining ceased, Bethlehem Mines reclaimed and stabilized mining operations at Cornwall, and this included permanently sealing the shafts of the No4 mine. The photo on the left shows the plaque mounted in the cement seal from the No4 shaft on August 24th, 1973. In time, the open pit filled with water. The deepest parts of the pit, not including the No3 mine beneath, are about 450 feet deep. The lake today on the open pit serves as a water supply for Elizabethtown, Pennsylvania. Big Hill today looks very similar to how it appeared when mining concluded in 1973, although more trees and plants are growing on the upper slopes, as nature slowly recovers the waste rock that backfills the core of the hill. For 50 years, the open pit loading pocket seen here was used to transfer ore from the open pit into rail cars sent to the concentrator plant in Lebanon. Today, you can still observe the stone placed in the wall of the loading pocket in 1909 by the Cornwall Ore Bank Company. The converted remnants of the loading pocket are used by PRL Industries today to conduct non-destructive examination and testing of metal components. Not much remains of the No3 mine. The head frame is gone, and the collar for the shaft is below the lake level at the west end of the open pit, close to Birdcoleman Village. The primary remnants are the foundations and pavements for the surface plant, and of course, the large waste rock piles that cascade down the north side of the pit into the lake below. Most of the buildings of the No4 mine surface plant and concentrator are now gone or dilapidated. Where the head frames of the No4 and No5 shafts once stood, you can only find the concrete seals and nearby foundations. The hoist house for the No4 shafts still stands, as does the primary jaw crusher that crushed most of the 35 million tons of iron ore produced from the No4 mine. Perhaps the best preserved monument to the years of mining at Cornwall is the Cornwall Furnace. Owned and operated today by the Pennsylvania Historical and Museum Commission, the furnace operated from 1742 until 1883, or about 60% of the time that the mines operated. The furnace also serves as a lasting testament to the relationship between the mines and the furnaces they supported for 236 years. During these many years, Cornwall mines produced a total of 106 million tons of iron ore, along with more than 133,000 tons of copper, 7,000 tons of cobalt, 335,000 ounces of silver, and about 50,000 ounces of gold. It's only fitting that I conclude my webinar presentation on the mining of Cornwall by thanking some of the key people who made the presentation possible. First, I want to thank Charlie Neal and his wife, Jean, which you can see in the upper banner. Charlie worked in the mines at Cornwall from 1937 until the mines closed. During his career, he amassed a large collection of information that Jean subsequently provided to Mike Trump of the Cornwall Iron Furnace Associates a couple years ago. And this collection, as Mike Emery mentioned, is the principal source material for my research on the mining at Cornwall. Second, I want to thank Mike Emery, Cornwall Furnace Site Administrator, and Karen Viozzi for their leadership and support of my research, along with Kathy Donaldson for coordinating this Zoom webinar. And finally, most importantly, I thank the men and women who labored and sacrificed during the 236 years of mining at Cornwall and milling at Lebanon and Cornwall. Their work won the metals in the ore to support our nation, and we collectively owe a debt of gratitude to the miners and millers for their labors and sacrifices. Thanks for listening tonight, and I'd be happy to answer your questions or listen to any comments.
Yes, Mike, we do have a couple of questions that came in, and this one was asked by Laura Weber. She wants to know, how do slushing drifts transport the rock?
So I'm trying to connect my camera here. But to answer the question, Dr. Weber, the answer is that They used large, like winches, scrapers, and those scrapers were used to, oops, make sure I'm upright there. Those scrapers were used to draw the ore through the slushing drifts down to where the haulage drifts were located, and then the haulage drift used locomotives to transport the ore to the loading slots nearby the shafts.
All right. Another question that came in, Mike, were there other minerals recovered manually in the early days before the concentrator plant was constructed?
That's a very good question, something I didn't really have time to get into. In the early days of mining at Cornwall, the miners did extract copper minerals, particularly from the upper part of the deposit in and beneath Middle Hill. The copper existed as both a native copper as well as copper oxides and copper carbonates. And those copper samples, specimens, were collected and then sent for subsequent refining down to Baltimore and other locations. In the years that the Cornwall Ore Bank Company operated in the 1800s, they would typically send anywhere from 100 to 300 tons of copper a year for off-site processing. Now, those high concentrated copper deposits gave out as the mining continued deeper into the ground. And so it took the development of the concentrator plant to actually resume the concentration and capture of those other metals that we talked about during the presentation.
Okay, we have another few questions here. And this is referring, I believe, to the subsidence. Was anyone in the mine when it collapsed?
So yes, miners were in the mine as it collapsed. The collapse typically occurs gradually. And as the miners were close to the surface, of course, when the collapses occurred, they were much louder and more obvious because there would be blasts of air associated with some of those early collapses. As the mining continued deeper, of course, the distance between the surface and the mining areas, the active mining areas, increased. So the sound and the air blasts became less noticeable. But I'm told by miners, both at Cornwall and at other mines, that you know when the ground above you is collapsing because it's something you don't forget.
I'm sure. We have another question here. Where did all the water go that was pumped out of the mines? Where was it piped and where did it go?
Initially, it was piped into local drainages. So Furnace Creek, you may know, typically flowed from behind, I guess, west of Miners Village towards the Cornwall Furnace. So that would have been an initial discharge point. Now, in the 1920s and 30s, of course, water pollution controls came into effect in the United States. And I know in particular, based on some recent research, that in the 1950s, sedimentation ponds were constructed for both the No. 3 mine, which also took water from the open pit, as well as the No. 4 mine. That series of laddered sedimentation ponds was used to drop out the suspended sediments, and then the water was discharged into local streams like Snitz Creek.
Okay, from Mike Freeland, we have a question. Were there any casualties in the mines during normal operation?
Yes, indeed there were. Unfortunately, we have records of several tens of miners who were killed in both the open pit and the underground mines during their entire lifetimes. The best records we have, of course, are after Bethlehem Steel took over the mining operation. But in addition to the fatalities that occurred during mining, it's a risky occupation to be a miner because of the surroundings and because of the heavy equipment that you use and the weight of the ore and the rock that you're extracting. And so in addition to the fatalities, you also have maiming injuries, all the way to much less severe injuries. Just an interesting footnote, as the mining progressed and safety improvements were made in the mining at Cornwall, it eventually came to a point where more time was lost by the miners from injuries that they incurred off the job than those that they occurred while they were on the job. So I think that's a real testament to the safety enhancements that were made for the benefit of the miners.
I have another question here. If the concentrator was around today, where would it be located? So the location of the concentrator.
The most recent concentrator is the photo that I showed near the No. 4 mine surface plant. So that would be located just, so you get my orientations right, just west of Tony's Mining Camp Restaurant. That little road that you drive into to access the area that used to be the No. 4 mine surface plant is the location where they built the concentrator beginning in 1960, began operating in 1962. And I point out that that concentrator actually operated after the mines closed because it continued to process ores that had been imported to the United States from other countries.
All right, we have a few more questions here. This is an interesting one. With advanced technology today, are there more deposits that have been found that were not known about before? So kind of going to the technology that was being used to find additional iron.
The area around Cornwall, I presume that's the scope of the question. Geologists have found additional deposits. In fact, because of the way that the ore deposits were formed at Cornwall, similar conditions exist throughout southeastern Pennsylvania in about an arc all the way from the Delaware River down to southern York County. Even in the Cornwall area, there are smaller deposits that are known because farmers would discover iron ore in their fields, or people would find clumps of unusual looking rocks. So it wasn't so much advancement in technology as it was just the desire that other people find similarly huge deposits of iron ore like were being mined at Cornwall. I mentioned Dr. Eagle and his history of Lebanon and Dauphin counties. And even back in the 1800s, he was documenting how the magnificence of the ore deposits at Cornwall really spurred interest by local people, farmers and others, to find similar deposits in the vicinity of Cornwall and the area.
Another question that we have here, this is from Tyler Gum. Were any of the ores metals provided to state or federal armories during the 19th century?
We do know that ore was supplied to support federal armories during the Civil War. So the answer is yes.
Okay, I'll jump in a little on this. I know that we were able to find a paper where the Navy actually was asking for iron to be sent down to a foundry in Philadelphia. And what they wanted is they wanted it for, I believe it was 50-pound projectile Dahlgren guns is what they were looking for. It was really early in the war in 1861. So we see paperwork where the federal government is actually coming in and asking for that. But we also know that a lot of iron is going down into the Philadelphia area and to northern Chester County, including places like the Phoenix Iron Works, which of course were making a fair amount of cannon and ammunition as well. So. this is something I think that you had covered, Mike, but I think it is worth saying before. Judith wants to know about the gold, silver, and cobalt and copper produced. I think we're really looking for, in what quantity was the gold and silver particularly produced?
Well, I mentioned throughout the course of the history of the mines that Cornwall produced at least 50,000 ounces of gold and about 350,000 ounces of silver. Now, it's important to recognize the massive quantities of ore that were being processed at the concentrator, which then allowed those very trace amounts of silver and gold and copper and cobalt to be recovered in the amounts they were recovered. When I'm talking about trace amounts, so even after the ore had been processed in the concentrator plant and most of the magnetic iron had been removed using the magnetic separation technique, the waste from that process was then subsequently concentrated to recover the copper concentrate. So if you take the copper concentrate, which by now is averaging about 20% copper in that copper concentrate, and that was sent off-site for subsequent refinement. In that material, on a per ton basis, they would typically be able to recover between 0.7 of an ounce of silver per ton of copper concentrate. And similarly, they could recover about 0.1 ounce of gold per ton. So it's a relatively small concentration, but again, by processing huge quantities of iron ore, which of course they produced during the course of the operation of the mines, they were able to recover significant quantities of gold, silver, cobalt, and then of course the copper.
All right, Mike, I think we'll do one more question. Were there any significant strikes or labor problems in the 19th or the 20th centuries?
Yes, in fact, there were. So I mentioned the Cornwall Ore Bank Company was formed in 1864. And that company came into existence in February of 1864. In April of 1864, the miners struck because they wanted better pay. So that's an early example of organized labor working specifically at the Cornwall mines. Now that tradition, of course, continued throughout, especially in the 20th century. And what I found generally in doing the detailed research of the mining under the auspices of Bethlehem Steel, most of the labor disturbances, organized strikes that occurred, sit-downs, were really done as part of a broader union response, the United Steelworkers, for example. And so it was less stimulated by local grievances and more as part of solidarity with a broader organized labor movement. But I will say this, at least as I could see in the records that I researched in the 20th century, the actions of the union leaders did help to not only improve the working conditions for the miners, but also, and the millers who were working in the concentrator plant, but it also enhanced safety because it really gave a platform for management and labor to come together and figure out what makes best sense to produce the minerals that they were there to extract, but also to ensure the safety of the workers.
All right, I believe we're right up against almost an hour. So I think we'll go ahead and end everything there. If you do have other questions that you might want to ask, if you'll just please go ahead and email those here to the site. My email is memery, so that's MEMERY @pa.gov. And I'm sure between Mike and myself, we'd be able to do that. Mike donning his miner's cap so thank you. So I'd like to thank everyone for joining us for this lecture. I especially want to thank Mike for his presentation and for Kathy Donaldson for helping to organize our virtual talk. I also want to thank the Friends of the Cornwall Iron Furnace who sponsored this program. If you or your business would like to sponsor a future lecture, please contact the site for further information. And of course, donations are gladly accepted. We look forward to the day when you can come and visit us at the museum again. But in the meantime, please stay safe and good night.